Dr. S.I.F. Philomen Raj, MSc, MPhil PhD, retired Head Department of Physics, Madras Christian College, Tambaram, Chennai. He is presently serving as a guest lecturer in Loyola College, Nungambakkam, Chennai. He has a teaching experience of 35 years in Madras Christian College for UG and PG students. His field of research is nuclear physics, and he has presented about 30 papers in symposia organized by Baba Atomic Research Center, Mumbai. He has guided 50 MPhil students and about 100 MSc students in their projects. He has authored practical physics books for MSc and BSc courses. He is presently engaged in writing a book on nuclear physics for Printers Hall, India.
Welcome to UGC lecture series in physics. We shall continue with nuclear and particle physics. In this session, we will be discussing about hypercharge and electric charge, the relation between the two, hypercharge and electric charge for elementary particles, and strangeness. There is a quantity called strangeness in elementary particles. We will discuss about that. And eightfold symmetry. You will find that particles, though there are so many particles, they all come in a symmetry. Nature has a symmetry. So, we will just discuss about these things. Hypercharge and electric charge. All of us know about the electric charge. Neutron is chargeless, proton has got a charge plus E, it has got charge. But according to Isenberg, the two neutrons and protons both have got something same, which is called hypercharge. Hypercharge will be same for neutron and proton, and only electric charge will be different. So, we will just discuss about that. A hypercharge is a quantity related to electric charge of isobaric particles. When you say isobaric, when you say the isobaric, that A you remember, isobaric refers to particles of same mass. Even in nuclear physics, when you say isobars, it is of same atomic mass number, same mass number. Particles of same mass number, that mass number refers to this A. You can remember as A, mass number A. So, it has got same mass number. Here in elementary particles, particles of same mass are grouped together and they are called isobaric particles. So, you have got so many elementary particles, and we find that neutron and proton have got almost same mass. They have got almost same mass in terms of energy. If you say the mass in terms of energy, it will be 931 MeV. So, neutron will have slightly higher mass, but both are the same range of mass. Therefore, we call it as isobaric particles. So, now these two, for example, neutron and proton are isobaric particles, and they will be having same hypercharge. We are yet to define that. So, hypercharge is given the notation Y, capital Y. Capital Y is for hypercharge. Y is constant for set of isobars. If you take set of isobars, it will have constant Y. Among the elementary particles, neutron and proton are a set of particles with same mass. So, they are isobars. Now, we will see how hypercharge is same for them. Hypercharge is defined as Y equal to 2 times Q minus Tz. What is this Q? Q is the electric charge of the particle, and Tz is the isospin component. See, the two particles both have got neutron and proton. If we take, they have got spin off. They are now spin off particles. So, they are called isospin, same spin. Isospin is off for neutron and proton, and one will take plus half, the other will take minus half. That plus half and minus half is called component. That is what we refer to as Tz. So, Y is equal to 2 times Q minus Tz. This is not a derived quantity, it is from observation. So, they found a lot of elementary particles from cosmic radiation. All the particles they segregated, sorted out, and then they found that neutron and proton alone have got the same mass range, and we have got mesons, different things. Neutron and proton as an example we take, because they have got same mass. So, they are isobars, they have got same spin, and what is different is the component, isospin component is different. So, this is from observation we write this equation, where Q is electric charge and Tz is isospin component. As we said, a neutron and proton both have got half, isospin half. Isospin component is plus half minus half. So now with this you just keep in mind this formula, y equal to 2q minus tz. With this we will just go further. So consider neutron and proton, they are isobars, particles of same, approximately same mass. Now why hypercharge? We said these two particles isobars will have same hypercharge. Now we will just see how it comes. So y is equal to 2q minus tz we said. Now if you take for proton q is equal to 1. It has got one charge, that is one electric charge. So q equal to 1. And it has got tz, as we said it is all spin-off particle. The proton is having plus half, neutron is having minus half. So tz is plus half. So when you substitute here, y is equal to 2q minus tz. This tz is written here. So what I get is 1 minus half, which is 1. This is tz equal to plus half. Therefore I will get 1 minus half is half, and here we get 2, so we get 1. So y is equal to 1 for proton, because tz is equal to plus half. And if you consider neutron, the formula is y equal to 2 times q minus tz. So y is equal to 2 times q0 minus tz. This is minus of minus plus, because tz is equal to minus half. So neutron and proton have got the same isospin half. Proton is having plus half, neutron is having minus half. So this one is substitute here, and I will find that y is equal to 1 again, and for neutron with this quantity. Therefore both have got y equal to 1. It is only the charge which is different, and isospin component are different. Thus neutron and proton have same hypercharge but different electric charge. Electric charge, that is what we observe. Electric proton has got charge 1, neutron chargeless. But hypercharge, something more than charge, that hypercharge is equal to 1 for these two particles isobars. Here Tz decides the manifestation of electric charge. So the electric charge is manifested because of this spin quantity. So when it is Tz is equal to minus half, you observe that it is charge is 0. The observed charge is 0 for neutron, and when it is plus half, observed charge is 1, electric charge is 1 for proton. Thus Tz decides the manifestation of electric charge. Heisenberg suggested that neutron and proton are same nucleon. He said both are not different, both are same, but one is having electric charge because of the isospin component. That is what he suggested. Heisenberg suggested that neutron and proton are same nucleon with different electric manifestation. So it is able to show us 0 electric charge, another is able to show us +1 electric charge. Both are same nucleon. So a group of isobars have same hypercharge. Now we have just example we said about neutron and proton, and it is true for all groups of particles. We will come to that. If you take a group of particles with same mass from elementary particle studies, maybe in cosmic radiation you will find so many particles coming. Some of them have got same mass. Suppose I find some 3 or 4 of them having same mass, then they are called isobars. Now we found that neutron and proton, there are 2 particles with same mass, and they have hypercharges same, namely it is equal to 1 for neutron and proton. Now we will just go further. Now there is another quantity called strangeness. So there are some particles which are called strange particles. This was observed by Gell-Mann and Nishima. And what they observed is from the hyperons. When you say hyperons, they are all from cosmic radiation, particles of higher mass higher than that of neutron and proton. They are hyperons. So they found that there are particles coming from cosmic radiation, and they observed that some particles are strange. When you say strange, what is that strangeness? Suppose I take a stone and I just throw a stone up. So if suppose it takes 3 seconds to go up, then it has to take exactly 3 seconds to come down. Suppose I am throwing it very fast, suppose it takes 4 seconds to reach the top, then it has to take exactly 4 seconds to come down. That is a normal behavior of a particle. Suppose I take a stone, throw it, it goes there in 4 seconds, and then I am waiting, it is not coming down. It is taking 4 minutes to come down. So it is taking 4 seconds to go up, it taking 4 minutes to come down. Then it is a some strange behavior. So that's called a strange particle. Similarly, this is for example I said. Now we will just go into detail. So strange particles are produced in high energy collision, but decay by weak interaction. So high energy collision, suppose I am throwing it very fast, high energy, but it is coming down like a feather, it is coming slowly, it is coming, that is a weak interaction. So it is coming slowly. So strange particles are produced in high energy but decay by weak interaction. So such a particle is called strange behavior, that is a strange behavior or strange particles. What Gell-Mann and Nishima observed is, along with other scientists, they observed that strange particles are produced in 10 power minus 23 seconds, very fast, 10 power minus 23 second, and they decay in 10 power minus 8 second. The order, I am just telling about the order. So here this is 10 power minus 23, decay is 10 power minus 8, which is not normal. A normal particle will be, if suppose this is going in produced in 10 power minus 23, that will also decay by 10 power minus 23. So then it will be normal behavior. Now here it is produced in short time and decaying longer time. So it is called fast production, slow decay. These are the characteristics of strange particles. That is what, as an example I said, throwing a stone upwards, for us to just remember, I just said that. So now the strange particles they are always produced in pairs. They are produced in pairs, the strange particles. They are not produced as a single particle, as a pair they are produced. What the scientists they observed is some quantum number, strangeness quantum number. So they want to make it mathematical, so that whatever you observe, they want to see what is the is there any mathematical, arithmetic or mathematical relation which can explain the reactions, because all reactions are not possible. Some reactions are occurring, some are not occurring. They found that it is related to that strangeness, related to strangeness of the particle. So they said, they defined a quantity called strangeness quantum number, and they gave a letter S for that. It is denoted as capital S, strangeness quantum number. S will be 0 for normal particles. If it is not a strange particle, that strangeness quantum number S equal to 0. S not equal to 0 for strange particles. If it is a strange particle, S is not equal to 0. It may be 1. Okay. From observation, what they found is S equal to y minus b. So they found out which are the particles which are strange. They found that already we defined what is that hypercharge. Hypercharge we just now defined. And B is nothing but baryon number. Suppose it is a baryon, it is B equal to 1. If it is not a baryon, B equal to 0. So from observation they found that strangeness S equal to y minus b from observation. This is not a derived quantity, it is from observation from the experimental data. For mesons, B equal to 0, because already in the elementary particles we have divided the light particles or leptons. L, you remember, for light, very light. Light particles are leptons, and then medium mass particles are mesons, and then heavier ones are called baryons, and still more heavier are called hyperons. Therefore, for mesons B equal to 0, because they are light they are only medium mass particles, they are not baryons. So B equal to 0. So for baryons and hyperons B equal to 1, because when you say baryon, neutron and proton are baryons, it has got mass 2000 times that of electron, and we go to hyperons, still more than 2000 times mass of electron. Therefore baryons and hyperons both have got baryon number 1, because they are large higher mass particles. From experiment they found that this Y, we have already defined Y, defined what is that hypercharge, and for neutron proton hypercharge is equal to +1, and there are another group of isobars which have got 0 and another group of isobars which have got -1. So, they are categorized. From experiment they found that there are particles with hypercharge 0, plus 1, minus 1. Accordingly, if I put here, they found that strangeness, if you put y equal to, so you have to substitute this y and this substitute this b. So, they found that strangeness can be 0, 1, minus 1, minus 2, because I have to substitute here. You put here this one 0, so you can substitute and see b equal to 1, 0. Then I will be getting for mesons all together, I will be getting these values. So, the possible values of S will be 0, plus 1, minus 1, minus 2. By substituting this y value and this b value, b can be two possibilities, b equal to 0 or b equal to 1. Y can be 0, plus 1, minus 1. If you substitute here, I can have the S possible values of S will be 0, plus 1, minus 1, minus 2. So, this is the strangeness quantum number. So, consider the following reaction like meson plus pi meson plus neutron will give you lambda plus k plus. So, this is a observed reaction in a cosmic radiations, you will observe this particular reaction. Then they found that if you see that spin value, the strangeness value, this one pi meson is not a strange particle and a neutron is not a strange particle. So, it is 0, and this side you observe that lambda is having minus 1 and this k plus is having plus 1 and the strangeness quantum number is conserved. Here it is left hand side it is 0, right hand side minus 1 plus 1 0. Because of this strangeness quantum number, they were able to explain the possible reactions. Certain reactions are possible, certain not possible by using this strangeness quantum number. With S, reactions can be explained, and also possibility of reaction can be tested, whether that particular reaction is possible or not. So, we have got for sigma is sigma plus I per on S equal to minus 1. This is all observed quantity, and k plus meson S equal to 1. Proton has got strangeness quantum number 0, neutron has got 0 and pi meson 0. So, these are the observed values from the reactions. Now, we will just go to 8-fold way or super multiples of baryons. So, we find that in the elementary particle studies, they found that there are 8 baryons, and how are they, what is that hypercharge, how are you symmetrical, they all fall in a diagram, symmetric diagram. We will just look into that. 8-fold we say because there are 8 baryons. Baryon, the same hypercharge, we already said if they are having same mass, they will have same hypercharge. That concept will be brought in here, and we will find that how we get that 8 particles as multiplets. Octet symmetry, because it is 8, we say is octet symmetry or 8-fold symmetry. So, there are 8 baryons all with spin off. If you take cosmic radiation studies, we find that there are 8 baryons all with spin off. So, they have to be grouped as same mass range, isobaric. So, you have to group as isobars. Then if you group as isobars, what you need to remember is if you group as isobar, that those isobars same mass range will have same hypercharge y, that you should, y hypercharge symbol y. So, that you should remember, and we will see that how do you get the 8-fold symmetry. So, we will just go into this diagram. So, this is baryon, and we are talking about only baryons. We said there are 8 baryons. So, we get proton, neutron, this is lambda 0, sigma plus, sigma minus, sigma 0, and this is psi 0 and psi minus. This is psi, you can pronounce as xi, psi 0 and psi minus. Now, these are the particles 1, 2, 3, 4, 5, 6, 7, 8 particles are all observed under cosmic radiation studies, and they found that they grouped as masses, all are grouped as small fellows, bigger fellows, like that. So, we find that mass are grouped this way. Neutron and proton have got approximately same mass, 938 MeV. Here again just you have to recall mass can be written in kilogram, and it can be written in terms of energy because of Einstein's relation E equal to mc squared. So, the energy can be written in terms of mass can be written in terms of energy. So, we are writing mass in terms of energy 938 in terms of energy we write. So, there are two particles we get, and then this lambda 0 we get only one particle. So, we will just go to this, and then sigma we have got 3 particles with the same mass region 1190, and this psi particles we have got mass region 1314. So, this is we are writing in the increasing order of energy. These are all baryons. Now, we will go to the third column. Neutron and proton, there are 2 particles, only 2 particles of this mass region. Therefore, we call it as doublet. We call it as doublet because there are 2 particles. Now, when we say doublet, you remember even in atomic physics, if L equal to 1, the degeneracy is 2L plus 1. So, if L equal to 1, it will be 3. If L, because why it is 3, plus 1 minus 1 0, 2L plus 1 is a degenerate. Therefore, generally we can write the formula for degeneracy as 2T plus 1. 2T plus 1 is the degeneracy. So, it has got 2 particles. Therefore, from this formula 2T plus 1, what you understand, T must be equal to half. Only when you put T equal to half, I will be getting 2, because 2 into half plus 1, that will be equal to 2. So, it means T equal to half. So, what is that T? T is the isospin. Isospin is half for these particles. So, this is the isospin you are writing. T is equal to half for this doublet, because it is doublet half. So, when you say half, what are the components possible? It will have plus half, minus half. So, this proton is having plus half, neutron is having minus half. These values we have. Now, what is hypercharge now? What is the hypercharge for this? Hypercharge is equal to y equal to, already we have discussed, we are just writing that here, y equal to q minus tz. Now, I will just go in detail for one particle. See, for neutron, for proton, we will consider the proton, y is equal to 2 into q is equal to 1, minus tz. Tz is equal to plus half. Therefore, what I get is, here I will be getting 1 minus half, which will be half, and outside we get 2. So, this will become plus 1. So, it will be plus 1. So, for just one column I will explain. Similarly, when you go for neutron, it has got minus half, and here for neutron the charge q is equal to 0. So, y equal to 2 into this is 0 minus of minus. So, we get this one. Therefore, I will be getting plus 1 here, plus 1 again, plus 1 here, which means both the neutron and proton have got same hypercharge y equal to 1. Now, we go to lambda 0. So, here what does 0 refer to? It refers to charge of the particle. The charge is 0, lambda 0. It has got 1115 MeV. Only one particle is having that mass. In the whole group of particles they studied, only this lambda 0 is only one particle with the energy 1115 MeV. Therefore, it is a singlet. Now, we use in this formula 2T plus 1, it is a singlet. It implies that T is equal to 0. So, we get T equal to 0, because it is a singlet, T is equal to 0. T equal to 0, there is no component. Tz is also 0, the component is also 0. And if you substitute here, y is equal to 2 into this charge q equal to 0, Tz equal to 0, therefore, y equal to 0. So, I will be getting for lambda 0, y equal to 0. Now, when you go to sigma, we get sigma plus, sigma minus, sigma 0. So, this refers to the charges, the superscript refers to the charges. So, you find 3 particles with mass 1190. Therefore, because there are 3 particles, it is a triplet. When it is a triplet, how do you get a triplet from this formula? I have to put t equal to 1. So only when you put t equal to 1, I'll be getting 2 plus 1 equal to 3. So it is a triplet. It's a triplet. Therefore, t equal to 1. T equal to 1 can have, what are the components possible? Plus 1, minus 1, 0. So this is plus 1, minus 1, 0. Just assigning plus 1, minus 1, 0, and if you just substitute here, y is equal to 2 into, the first case is, this is plus. So I will be writing 2 into, this is plus, and then this one is plus 1, plus 1. So plus 1, and here we will get minus 1. Therefore, y is equal to 0. Y equal to 0. Similarly, for this one, this is minus 1. Therefore, this will be q equal to minus 1, and then this one is minus of minus 1 plus 1, 0. Therefore, we get y equal to 0. If we substitute, you will know what is happening. So all the 3 particles will have y equal to 0. This is sigma 0. This is q equal to 0, and also Tz equal to 0. Therefore, y equal to 0. So they found that the quantity hypercharge is remaining constant for a set of isobars. Similarly, when you go to psi particles, psi 0 and psi minus, there are 2 particles with the energy 1314 MeV. This is the energy. Therefore, it is a doublet. It is a doublet. Here we get doublet. So as in the case of neutron proton, here it is a doublet we get. So when it is a doublet, naturally if you use in this formula 2t plus 1, I have to put t equal to half. Only then I will get 2 into half plus 1, which will be 1 plus 1 equal to, so we will be getting 2. Therefore, Tz equal to, I will be getting, t will be plus half, the components will be plus half and minus half. So the same thing, psi 0 plus half and psi minus half. And here if you substitute, y is equal to 2 into q minus 2Ez. So here this particle has got charge 0. So I have to put 0 here, 0 minus, and I will get Tz equal to plus half. Therefore, I will be getting minus 1, because there is a 2 outside. If we take this, this will be, I will be getting minus 1. Similarly, if we take psi minus, I will be getting, this is minus half. This charge is minus here. Therefore, I will be getting y equal to 2 into, this charge is minus, and also this one Tz is minus. So I will be getting minus 1 here. So this is the pattern in which the 8 baryons were fitting. So it is called super multiplets of baryon, and it will be called as octet because there are 8 particles. For all these baryons, there are 2 variables. One is Tz is a variable, and y, there is hypercharge. So we can always draw a diagram. Maybe we can take Tz in the x axis, and we can take hypercharge in the y axis. If you do that, I will be getting the diagram, what we just see the diagram in the next slide. So here, whatever we discussed, that T is isobaric spin for the tabular column. Tz is isospin component. We found that hypercharge is conserved for isobars. We have been explaining that. Now we will just go to what is called weight diagram. Weight diagram, what we will find is, it will be falling in a hexagon. We will just go into that. So yeah, this is the weight diagram for baryons. So we are able to see that y is equal to plus 1, 0, minus 1, and this is Tz. Tz already we saw in the tabular column. We have got the values ranging like this, minus 1 to plus 1, we get the values ranging, and all the particles, the 8 particles are fitting into this. Now this is actually an hexagon, but 8 particles are 1, 2, 3, 4, 5, 6, 7, 8 particles. We have discussed hypercharge and electric charge. The concept of strangeness we took into account was also discussed, and I explained the 8-fold symmetry with the weight diagram. The weight diagram is an interesting thing. There is symmetry in nature. So we will just put a few questions for the day. Write down the relation between hypercharge and electric charge and explain isospin. What are strange particles? Give examples. Explain 8-fold symmetry and super multiples of baryons with weight diagram. So in the next class we will be going to 8-fold symmetry for mesons and weight diagram for that. Thank you.